Year 21 core OpenGL core profile OpenGL tutorial. So in the last tutorial we talked about some other steps of the pipeline. So in this tutorial, the output of the geometry shader is then passed onto the rasterization stage, so where it maps the resulting primitives to the corresponding pixels of the final screen, resulting in fragments for the fragment shader to use. Before the fragment shader runs, clipping is performed. Clipping discards all fragments that are outside your view, increasing performance. A fragment in OpenGL is all about the data required for OpenGL to render a single pixels. The main purpose of the fragment shader is to calculate the final color of the pixel, and this is usually the stage where all the advanced OpenGL effects occurs. Usually the fragment shader contains data about the 3D scene that it can use to calculate the final pixel color, like light, shadow, color of the light, and so on. After all the corresponding colors value has been determined, the final object will then pass through one more stage that we call the alpha test and the blending stage. So in this stage checks the corresponding dip and tensile value, where we'll get to those later. Check the corresponding dip value of the fragment and use those to check if the resulting fragment is in front or behind other objects and should be discarded accordingly. The stage also checks for alpha value. Alpha value defines the opacity of the object and blends the object accordingly. So even if a pixel output color is calculated in the fragment shader, the final pixel color could still be something entirely different when rendering multiple triangle. As you can see, the graphic pipeline is quite a complex whole. The graphic pipeline is quite a complex whole and contains many configurable tasks. However, for almost all the case, we only have to work with the vectors and fragment shader. So most of the case we are going to be working with the vector shader, then the fragment shader. The geometric shader is optionally and usually left to its default shader. In modern OpenGL, which we are doing, we are required to define at least a vectors and a fragment shader of our own. There are no default vectors and fragment shader on the GPU. For these reasons, it is often quite difficult to start learning modern OpenGL, since a great deal of knowledge is required before being able to render your first triangle. Once you do get to finally render your triangle at the end of this chapter, you will end up knowing a lot more about graphic programming. So in the next tutorial, guys, I'm sorry for the shortness of the tutorial, but see me in the next tutorial. We'll talk about the vectors input, which is the input to the vector shader, then before to the fragment shader. So bye for now. Don't forget to subscribe, like, share and comment. Yeah. So see me in the 22